Now, I don't want to spook you, but there's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaitre constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaitre constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we might all live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies, kind of like between my ears. They make our entire world look like a big sponge. Now, let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density, called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long period of time, creating massive structures, galaxies. Galaxies are arranged in huge walls and filaments, with enormous gaps in between. And these gaps are voids, also known as dark space. Now, these voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about a tenth of the average matter density, which is why we consider them nearly empty. Usually, they'll have a diameter ranging from about 30 to 300 million light-years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands of light-years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yeah, it's basically a big dark vacuum. But even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our universe. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what the thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness of about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that's possible, so scientists keep arguing over this one. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace on our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists call this the local hole. The discovery of the local hole may hold clues to explaining the Fermi Paradox. Maybe in this specific part of the universe, where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all of the sentient beings hang out somewhere beyond our supervoid. But that doesn't mean we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the Sun and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2, but if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life even in our solar system alone, not even mentioning all the planets and galaxies we found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler-186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem. Are we really by ourselves in the universe? It's a daunting question that's been haunting us for centuries. No wonder scientists have tried to come up with all sorts of ideas as to why. One of the strangest theories concerning our lack of contact with other life forms is named the dark forest theory. Let's start small, well, sort of. We'll focus on our Milky Way for now to better understand this theory. Our cosmic neighborhood is a galactic wonderland, sprinkled with 200 billion twinkling stars and maybe around 100 billion planets. So let's get hypothetical for a moment and say a tiny part of those habitats hosts life. Further, out of those life-bearing planets, a few might have evolved into intelligent beings. Given that, You'd think we'd be knee-deep in weird-looking neighbors, some of whom might be actively trying to find us or might just be out there, waiting to be discovered. Now, let's put a little science into this science fiction scenario. We have something called the Drake equation, which is a kind of universal roll call that estimates how many smart civilizations could pop up in our galaxy. You can think of this equation as the super smart roadmap. By playing around with a few important factors, the equation hints that there should be around 20 civilizations just in our galactic backyard. So why haven't we stumbled upon any yet? This theory isn't an easy task. It's a mixed bag of multiple variables, like the average number of planets per solar system that could potentially host life, or the rate at which stars suitable for intelligent life are formed. A tricky part here is that astronomers have yet to solidify the exact values of these variables, which means our calculations are just approximations for now. But back to the Milky Way, shall we? Feed in our hypothetical assumptions, crunch the numbers, and you get at least 20 civilizations. Yet somehow, our cosmic switchboard remains weirdly silent. How come? This radio silence has its own name, too, the Fermi Paradox, named after the guy who first thought, "Hey, where is everybody?" over 50 years ago. Since then, we've had a lot of different theories trying to solve this mystery, all tinkering with different aspects of the Drake equation. Some folks think the appearance of life is a rare event. Others think that getting from bacteria to advanced beings is the tricky part. Yet, some reckon that civilizations might either wipe themselves out after a short lifespan or never even get to invent something they could communicate with. But there's one theory that tops all others in its creepiness: the dark forest theory. According to it, the universe is a huge cosmic version of a haunted forest. And other types of creatures are out there, playing a game of hide and seek. They're intentionally keeping silent. Why? Well, the dark forest theory was best explained in a sci-fi novel, and the rationale goes something like this. For starters, every life form wants to stay alive. I'll buy that. If we go with that assumption, it's impossible to be sure whether other life forms might harm you if they get the chance. So, the safest bet is to take them out before they find the right time to do the same to you. Frankly speaking, it's the universe's version of the survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being traced and you being wiped out. How human. This results in everyone keeping quiet, a kind of universal shush, where every civilization tries to hide in utter cosmic silence. But hey, is this just an idea good for a thrilling novel, or does it have some real-world implications? Well, the theory was suggested by scientist David Brin as a possible explanation for the lack of radio evidence for non-Earth-like life. He went as far as imagining it would be robots that would do the dirty work of wiping out civilizations. But how realistic is this theory anyway? Well, it doesn't require us to assume a lot of stuff about the behavior of all foreign civilizations. Just one advanced race behaving this way could explain our observed reality. And it might explain why we've not picked up any advanced radio chatter despite a century of eavesdropping. It's possible that other creatures like us are too terrified of being noticed and have gone radio silent on purpose. But, and it's a big but, like mine, it does base itself on the notion that other species share our level of risk aversion and logic, or that there's a rogue civilization out there, picking off anyone they perceive as a threat. And that's a pretty significant assumption. If that doesn't sound creepy, this next piece of information certainly will. For about a century now, we've been shouting our existence into the cosmos. If this theory proves to be correct, every other civilization within 100 light-years of us might be getting our signals and knowing exactly where we are. And if we have reasons to hide from them, as suggested by some like Stephen Hawking, we might already be in trouble. But what if this theory isn't true? What if, sooner than we'd like to imagine, weird galactic creatures will indeed try to reach us? The truth is, most of us wouldn't even know what to do. Hey, let's not get over ourselves. In fact, some scientists are tackling this issue head-on. For the first time since the 1980s, specialists are trying to cook up a how-to guide for when we inevitably bump into cosmic neighbors. For instance, some researchers believe we've got to do more than just worry about how these life forms could shake up our world. If they send any type of radio signals down here, we've got to think about our reply. What are we going to say? Hey, we're humans. Nice to meet you. Absolutely not. We've got to do better than that. See, the only plan we've had till now came from a rough blueprint dating from 1989. This guide is a bit wishy-washy on what to do when the entire world gets the outer worldly text. Mostly it says, hey, let's share the news with everyone. But then what? If we confirm it's legit, officials will need to ask the United Nations for advice. But hey, does the United Nations even have a plan? Maybe, who knows? We've been doing loads of space exploring lately. Some say we've stumbled upon water on Mars. Others are sure we've spotted some planets that could be twins to Earth. So, the idea of finding life elsewhere isn't that far-fetched. But even after 100 years of trying to chat with cosmic beings, it's still a one-sided conversation. This new protocol isn't just about chatting up outsiders. It's also going to act as our cosmic voicemail, checking messages from outer space. It aims not just to decode the external lingo. It's also planning to figure out what these messages could mean for us. The plan is also to draft reports about how different policies could impact us and set up guidelines on how to respond to these space texts. So, will we ever get a message from our cosmic mates? Only time will tell. But what we do know is that we just can't wing it. We can't be caught off guard and start a planet-wide frenzy when we get that otherworldly WhatsApp. We gotta have a plan, and we gotta have it ready for when we're face-to-face with the real deal. I mean, we've come across a lot of potential such sightings, but none of them proved to be genuine. On that note, U.S. authorities checked over 100 cases of weird stuff going on in the skies. I'll spare you the details, but not one green creature was ever found. More like drones and similar stuff floating around. So, as we stand on the cusp of this potentially game-changing event, we must strive to be prepared. Whether our intergalactic neighbors drop us a text tomorrow or centuries from now, we need a plan. After all, this could change everything we know about our universe and our place within it. Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub C is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi Paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides, so they're intentionally avoiding us because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi Paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, They may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi Paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
If the multiverse theory is correct, ours is not the only one out there. Which is as interesting as it is scary, right? Now, not every scientist is on board with this mind-bending concept. And let's be honest, the idea of actually making contact with these parallel universes sounds about as probable as winning the lottery while riding a unicycle. But hold on tight, because this strange concept isn't just limited to the realms of fiction anymore. Believe it or not, a bunch of scientific theories actually support the existence of parallel universes. And let me tell you, it's a topic that stirs up quite the debate in scientific groups. Now picture this. The universe we live in is mind-numbingly vast. We're talking billions, some say even trillions of galaxies swirling around, each packed with an almost uncountable number of stars. Some brainiacs studying the universe's shape suggest that its diameter could span a staggering 7 billion light-years. Others even argue that it might be infinite. Could there be more out there than meets the eye? Well, real scientific theories are exploring the possibility of universes existing alongside, beyond, or even mirroring our own. These intriguing concepts of multiverses and parallel worlds often intertwine with other, more familiar scientific ideas like the Big Bang, string theory, and quantum mechanics. In order for us to figure out what's out there, we have to rely on the information we're a bit more confident in, right? Let's rewind the cosmic clock about 13.7 billion years ago. Everything we're able to see today was squished into a minuscule singularity. Then, if the Big Bang theory is to be trusted, it all went boom. The universe inflated with a speed faster than that of light everywhere, within less than a second. The way the universe went pop has led some clever researchers to ponder the existence of more than one universe. They question whether that sudden growth ended everywhere at the same time. While the expansion ceased for everything we're able to see from Earth 13.8 billion years ago, cosmic inflation might still be ongoing in some other mysterious corners. Some theoretical physicists say that as inflation ends in one place, a new balloon universe forms. But here's the catch: you can't just hop from one bubble to another like intergalactic tourists. These bubble universes are expanding indefinitely, and their edges are zooming away from us faster than light can travel. And here's where things get even more confusing. Let's say we somehow manage to reach the edge of our local balloon and encounter the next universe. Well, those same theoretical physicists mentioned that the neighboring universe could be a whole different ballgame. It might have completely different laws of physics, making it a bizarre place for us. Following the same idea, Some say that in this vast multiverse of bubble universes, there might be other life forms just like us. The problem is, we're getting farther away from them with each passing moment, and our paths will never cross. Other super smart researchers out there are trying to connect parallel universes with quantum mechanics. Now, quantum mechanics is basically the fancy math behind teeny tiny particles. According to it, these particles can exist in multiple states all at once. They call it a wave function that holds all the crazy options. But here's the catch. When we observe these particles, we only see one outcome. It's like the universe keeps playing hide and seek with us. Now, there's this theory called the many worlds theory that says whenever we observe one outcome, another universe pops up where a different outcome becomes real. It's like our universe acts as a giant tree, constantly branching into countless versions of itself. These alternate universes can't mingle, though, so you wouldn't even know if there are a bunch of other yous living slightly or totally different lives. This many worlds theory is pretty bold and a bit hard to prove or disprove. And that's not great for science because scientists love to test and experiment with their ideas. But if there's infinite space out there, why wouldn't there be infinite universes too? Try to imagine the universe as this giant cosmic playground. Some specialists believe that if it's indeed never-ending, then there's only a limited number of ways that its building blocks can arrange themselves. Eventually, they have to repeat certain patterns. If this is true, then it may be possible that somewhere out there, there might be another version of you living the exact same life, even down to what you had for brunch yesterday. Did we ever have any proof of these supposed parallel universes? Well, some say we did. Have you heard the tale of the mysterious man from Torid? It's the story of a man that ended up at a Japanese airport saying he was from a totally unknown country called Torid. Now, some folks think it's proof of time travel, while others believe it's evidence he came from a different universe altogether. As much as you'd like to believe the story to be factual, the tricky part is this Torid place. There's a reason you haven't heard of it. There's no Torid to be found, whether in the present day or back in the 1950s when this supposed incident happened. After the airport incident, the man just vanished into thin air a day after arriving in Japan. Poof, gone forever. Let's rewind to that fateful day in July 1954 when the man from Torid supposedly landed in Tokyo. Descriptions paint him as a bearded, French-speaking man. Nothing too outlandish so far, right? Depending on who's telling the story, things start to diverge a bit. In one version, when the man hands over his passport to get stamped, the Japanese officer's eyes bulge out. While the passport looked legit, the country listed as Torid isn't recognized by anyone, including the officer and other officials. Naturally, they take our Torid visitor away for a little Q&A session. In another version, the man straight up tells the officer he's from Torid and shows him the passport when he doesn't buy it. Our man from Torid then started trying to convince the officers that his homeland is the real deal. According to him, Torid sat snugly between France and Spain and would have been around for about 1,000 years. To prove his point, he even points to the area on a map that matches the Principality of Andorra. Obviously, things took a mysterious turn. The officers decided to hold the man in custody, suspecting he might be up to no good. They put him up in a nearby hotel for the night, but not without stationing 2 people outside his room to keep an eye on things. Can you guess what happens next? Drumroll, please. When the officers showed up the next morning, ready to continue their investigation, the man had vanished without a trace. No sign of escape, and to make matters even more puzzling, all his personal documents have magically vanished too. What if the man from Torid was a time traveler or an intergalactic adventurer? Some have even delved into the realms of science fiction to explain this bizarre event, and you won't believe the number of people on the internet who've latched onto it as evidence for alternate realities. One of the weirdest ideas suggests that the man accidentally stumbled into a parallel dimension and ended up at the Japanese airport. In that parallel universe, there's an Earth just like ours, but instead of Andorra, they call it Torid over there. Another idea floating around was that the man was a time traveler from the future. Sorry to break it to you, but the most reasonable explanation for the whole story of the man from Torid is that someone's imagination went wild. Since there are many versions of the same story, it's probable people just kept adding outrageous details to the case to make it more sensational. The whole story simply snowballed into an urban legend, and there's little to no reason to believe we've once seen a time traveler or intergalactic hitchhiker right here on Earth.
New research suggests that Mars might have all the necessary conditions for the appearance of life. Does it mean aliens could be already waiting for us on the red planet? Let's figure it out. On Mars, there are just the right conditions for photosynthesis beneath dusty ice layers in its mid-latitudes. And photosynthesis, the process used by plants, algae, and cyanobacteria to turn light into chemical energy, requires water and sunlight. On Mars, a thick layer of ice might filter out harmful solar radiation while letting enough light through to enable photosynthesis, creating what researchers call radiative habitable zones. This doesn't mean that, at the moment, life exists or has ever existed on Mars. At the same time, the findings give scientists clues about where to search for potential signs of life. Both Earth and Mars lie within the Sun's habitable zone, where temperatures can support liquid water. But while our planet's surface is covered with huge oceans, Mars appears dry and desolate. Yet evidence from NASA missions like Curiosity and Perseverance suggests it wasn't always this way. Ancient lake beds and river channels show that water flowed on Mars billions of years ago. Today, water exists on Mars primarily as ice, often in surprising locations. Scientists believe Mars lost its liquid water when its magnetic field faded, which led to its atmosphere getting stripped away by solar winds. With little atmosphere left to trap heat, water vapor escaped into space, leaving the surface cold and dry. Without an ozone layer, Mars also faces intense ultraviolet radiation, which destroys the complex molecules essential for life. Mars gets about 30% more harmful UV radiation than Earth. But dusty ice layers could shield potential habitats from this radiation while still letting in enough sunlight for photosynthesis. Using computer simulations, researchers found that dust within Martian ice could cause it to melt from below, forming thin layers of liquid water. These pockets could be shielded from evaporation by the overlying ice, creating the two essential ingredients for photosynthesis: water and sunlight. Past studies also suggest that even small amounts of dust, less than 1%, in dense Martian snow, can enable melting in mid-latitudes. Observations of exposed dusty ice near Martian gullies also support the idea that these conditions could form shallow liquid water layers under the surface. At the same time, the amount of dust in the ice plays a critical role. Ice with too much dust blocks sunlight, while ice with just the right amount, from 0.01 to 0.1%, can create habitable zones at depths of 2 to 15 inches. Cleaner ice could allow these zones to form deeper, between 7 and 10 feet. As for Mars's polar regions, even though they're rich in ice, they are likely too cold for this melting to occur, making mid-latitudes a more promising target. Interestingly, similar habitats exist on Earth, providing an analog for what might happen on Mars. On Earth, cryoconite holes form when dust and sediment heat ice surfaces, melting them enough to create pockets of liquid water beneath. These translucent ice layers allow sunlight to go through, and researchers have discovered microorganisms living in these shallow subsurface environments. While they go dormant in winter, when sunlight returns in the summer, it reactivates these tiny ecosystems. While this research doesn't confirm the existence of life on Mars per se, it does open up new avenues for exploration. Understanding how dusty ice interacts with sunlight and melts could help identify potential habitable zones on the red planet. The research team is planning to refine their simulations to better pinpoint where and when melting might occur on Mars. They're also recreating these conditions in the lab to study them in greater detail. This work could provide important insights for future missions looking for signs of life on Mars. One of the biggest questions that has been torturing the minds of astronomers and common folks is, why haven't we found aliens yet? You'd think with a universe so big and filled with tons of stars and planets, we'd have already bumped into some extraterrestrial neighbors by now. This question was first asked by famous physicist Enrico Fermi during a lunch with his fellow scientists. They were chatting about UFO sightings and aliens, and suddenly Fermi asked, "Where is everyone?" It seemed like a casual comment, but it sparked a huge debate. If the universe is packed with stars, planets, and the possibility of alien life, how come we haven't seen any yet? This discussion gave birth to something we now call the Fermi Paradox. It goes like this. Based on what we know, there should be advanced alien civilizations out there, perhaps even many of them. They'd likely have technology that could allow them to travel across space or at least send us signals to let us know they're there. But here's the kicker. Despite all of our technology and all the searching we've done, we haven't found a single shred of solid proof that these advanced civilizations do exist. So where are they? Over the years, a lot of theories trying to explain this paradox have seen the light of day. Let's talk about some of the most interesting ones. The rare Earth hypothesis claims that Earth might just be super rare, and planets like ours, with life, are incredibly uncommon. In this case, we could be the only planet in the Milky Way harboring life, or at least intelligent life. We might also be the first intelligent civilization in our galaxy to reach this level of development. In other words, we could be pioneers, however unbelievable it may sound. At the same time, it's not very scientific to rely on a rare chance. Some people think that maybe advanced civilizations were once here, but left the Milky Way. Perhaps they developed the technology of interstellar travel, enabling them to fly between galaxies. Or they could use other exotic ways, like wormholes, hypothetical structures connecting disparate points in space-time. Maybe they found more interesting and pleasant places to live far away from us. One sad possibility is that when a civilization becomes too advanced, it ends up destroying itself. Whether through war, environmental destruction, or something else, it could be that most civilizations don't last long enough to reach out to others. Now, imagine an advanced civilization being wiped out by a disease before they could even start exploring stars. In other words, it's possible that civilizations just don't survive long enough to meet others. Another hypothesis, not very flattering to us. What if these aliens are using technology that we just don't understand? Maybe they're communicating in ways we can't detect, like using signals beyond our current understanding of physics. Scientists are discussing such possibilities, but haven't found any yet. Aliens might also be intentionally avoiding us. They could be out there but staying silent, not so eager to reveal themselves until we're ready. Speaking of being ready, some people think that aliens could be waiting for us to reach a certain level of development before they make contact. Maybe they don't want to interfere with our growth until we're more advanced. Advanced civilizations could also go into virtual realities. And if they can live in digital worlds, they might stop caring about exploring the physical universe. Why bother? Another wild idea is that some civilizations might go into a type of hibernation, waiting for the universe to cool down, because it might be more energy efficient to do so. And last but not least, there's this creepy possibility that our entire universe is a computer simulation, and aliens are hidden from us on purpose. It's something like a video game that doesn't reveal all its secrets at once until you get to the next level. Now let's talk about the odds of life out there. We know that in just our galaxy, the Milky Way, there are probably around 20 billion planets that are roughly Earth-sized and located in the habitable zone, which means they're just the right distance from their stars to have liquid water. But how many of these planets actually have life? Could it be most of them, just a few, or almost none? And out of the planets that do have life, how many host intelligent beings with technology? In the 1960s, a scientist named Dr. Frank Drake tried to estimate the number of civilizations in our galaxy that could contact us. He came up with a famous equation, later called the Drake equation. It looks complicated, but the idea is pretty simple. It helps us calculate the number of intelligent civilizations based on things like how many stars are born each year, how many have planets, how many planets could support life, and how long a civilization might last. Here's what it looks like. Let's look into this equation in more detail. N is the number of intelligent civilizations that could contact us. R is the rate of star formation in our galaxy. FP is the fraction of stars with planets. NE is the average number of planets per star that could support life. FL is the fraction of those planets where life actually develops. Fi is the fraction where intelligent life arises. Fc is the fraction of civilizations that can and want to communicate. L is how long these civilizations last before they disappear. The problem is, we don't know the exact values for most of these factors. So when we plug in numbers, which we know with large errors, we get answers with very large errors too. Depending on the values, the number of civilizations in our galaxy could be anywhere from almost 0 to tens of thousands. Right now, the best estimate we can come up with gives us a very small number, close to 0. In other words, even though our galaxy is huge, it's possible we're all alone here. Or nearly alone. One big reason we haven't met any aliens yet is that even if they do exist, we might not be able to visit them, at least not with our current technology. The speed of light is a hard limit in physics, meaning nothing can travel faster than it. This makes interstellar travel super slow. The situation could be better if there were exotic ways of travel, such as wormholes and warp drives. One day, they may turn out to be real, but so far, there is little hope for that. Even if we can't meet aliens face to face, there are still ways we might discover them. One of the biggest projects is called SETI, Search for Extraterrestrial Intelligence. SETI scientists use huge telescopes to listen for radio signals from distant planets. If an alien civilization is sending out signals, we might be able to pick them up. And if we have a very powerful telescope, we might use it to take super detailed pictures of distant planets, maybe even Earth-like ones, hundreds of light years away. This could give us a whole new way to search for signs of alien life. In any case, even though we haven't found aliens yet, the search is far from over. Whether it's through new technology, better understanding of physics, or just listening to the stars, we might one day find that we're not alone in the universe. Until then, the question, where is everyone, keeps sparking curiosity.
According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radiopanspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven.
Did you know that reports of strange object sightings are quite common? The British Ministry of Defence reports at least 100 UAP, unidentified aerial phenomena, sightings every year. That means there have been at least 2,400 reports in that country alone since the year 2000. A UAP is considered to be anything that cannot be immediately explained or identified. Usually, most reports find an explanation, such as atmospheric phenomena or known objects. However, the portion that remains unexplained is undoubtedly the most intriguing. Throughout history, there have been waves of sightings. One of the most well-known occurred in 1947, famously referred to as the flying saucer madness. That summer saw a flood of reports across the United States, with approximately 800 sightings that year alone. On that occasion, a local news story reported by a civilian pilot named Kenneth Arnold claimed to have seen disc-shaped objects traveling at speeds of around 1,200 miles per hour in a line of 9, passing over Mount Rainier. This was the first post-World War II sighting and is considered the report that marks the beginning of the modern UFO era. Returning to this century, there are at least 15 well-known cases. Let's examine some of the most striking examples. Number 1. The first case we'll look at has even sparked NASA's interest. It concerns the unexplained activity in a small town in the United Kingdom called Bonsall. Residents have reported and documented numerous cases of unexplained activity, earning it the nickname UFO hotspot. Reports range from silver shapes to strange lights in the sky. In 2001, Sharon Rowlands accidentally filmed a house-sized disc with colored lights around it. The video caught NASA's attention because it resembled an object spotted during a 1996 space mission. However, the only conclusion NASA reached was that the object was metallic and didn't match any known commercial or military aircraft. Number 2, this case is from 2004 and concerns the Tinley Park lights in Illinois, United States. Residents reported inexplicable lights in the sky, which were also seen in neighboring cities like Chicago. Witnesses claimed to have seen a triangular pattern of red orbs hovering over the town. Other witnesses stated that the lights displayed a range of colors, from amber to greenish yellow. Skeptics who saw the lights firsthand dismissed them as an elaborate prank, but no definitive explanation was found. The lights were seen twice that year and remain a mystery to this day. Number 3. The next case involves some of the most viewed footage of sightings. The unexplained videos from 2004, 2014, and 2015 recorded by pilots of the USS Nimitz and USS Theodore Roosevelt. The fighter jets managed to capture these strange flying objects using their infrared tracking cameras. In 2021, the Pentagon officially confirmed the authenticity of these recordings. Fighter pilot Commander David Fravor of the Nimitz stated that the object had been appearing for 2 weeks when he was called to investigate the case. The object appeared at an altitude of 80,000 feet, descended rapidly to 20,000 feet, and then hovered. Fravor reported seeing an oval-shaped object approximately 10 feet, 3 meters long flying over the ocean. He and other pilots accompanying him stated that they were able to observe the object for about 5 minutes before it disappeared. It was Commander Chad Underwood, in a second wave of investigation and equipped with an infrared camera, who managed to capture the first video showing the object's erratic movements. Number 4. This case occurred in 2006 and is known as the O'Hare International Airport sighting in Chicago. Around 4:15 p.m., 12 United Airlines employees and several witnesses outside the airport saw an unidentified flying object resembling a flying saucer. The object was hovering over gate C-17. It was also seen by pilots, airline staff, and mechanics. Witnesses described it as completely silent and dark gray in color, adding that it clearly wasn't a cloud. A witness claimed that the object shot upwards at incredible speed, leaving a hole in the clouds that quickly closed. Despite numerous testimonies from people shocked by what they saw with their own eyes, authorities refused to pursue an investigation, as the alleged craft did not appear on any radar. Number 5. This case was cataloged as the 2024 New Jersey drone sightings. Interestingly, the appearances occurred on both the east and west coasts of the United States multiple times. These large, unidentified drones were seen near residential areas, power plants, railways, highways, and critical infrastructure, such as ports, bridges, and police stations. Over 3,000 reports were collected, but investigators couldn't determine an explanation. The Department of Homeland Security stated that the drones were manned aircraft operating lawfully. At the same time, the federal government called for legislation and additional resources to address the drone activity. According to a legislative briefing, the drones were up to 6 feet, 1.8 meters in diameter, operated for 6 or 7 hours, often turned off their lights, acted in a coordinated manner, and evaded detection. They most certainly did not seem to be flown by hobbyists. To this day, the operators or points of origin remain unidentified, but official investigations attributed most of the drone sightings to manned aircraft or misidentifications caused by nighttime illusions. Some even suggested mass hysteria, recalling the notorious 1947 flying saucer madness. Which of these cases sent chills down your spine? Let us know in the comments. And if you're curious about the latest unidentified phenomena, don't miss our video on the FBI's recently published UFO documents. It's the year 1977, and astronomers are stunned. They've just picked up a bizarre and really powerful radio signal coming from the direction of the constellation Sagittarius. The signal shockingly matches the frequency of neutral hydrogen. What's the big deal? This is the very frequency many astronomers believe might be used by extraterrestrial civilizations trying to communicate. Since then, the signal has become legendary in the search for extraterrestrial intelligence, aka SETI, community. But what exactly was that mysterious signal? To understand this, let's go back to the 1970s when the Ohio State University Big Ear Radio Telescope was active. For more than 2 decades, from 1973 to 1995, it played a major role in the university's SETI program. By the way, it was the longest-running SETI project in history. And in 1977, Big Ear detected something extraordinary, the WOW signal. This wasn't just any signal. It was a strong, narrowband radio signal, right near the important neutral hydrogen frequency. The Big Ear telescope might be gone now, but the mystery of the WOW signal still fascinates scientists today. Imagine this. You want to tell an extraterrestrial civilization about humans. How would you describe our average height? We can't use feet or inches because these units mean nothing to them. Even here on Earth, we don't all use the same measurements. To communicate with other civilizations, we need a universal way of conveying information. Luckily, the emission of light by matter comes from an electron jumping between quantum states in an atom. This process, governed by quantum mechanics, results in specific and fixed radiation frequencies and wavelengths, no matter where you are in the universe. Since we believe the laws of physics are the same everywhere, these wavelengths are universal. This makes them a perfect standard of measurement that any civilization could understand. For example, on the Pioneer spacecraft's gold plaque, we used a particular wavelength as a unit of length to describe information about humans and the spacecraft's origin. So, if an extraterrestrial civilization wanted to talk to us, they could have used the frequency of the wow signal. And that's pretty amazing. The signal lasted the entire 72 seconds that Big Ear was tuned in. A few days later, astronomer Jerry R. Amon was looking over the data when he spotted the unusual signal on a computer printout. He was so surprised that he wrote "wow" next to it, and that's how the signal got its famous name. The signal also has another, not-so-exciting name, 6EQJ5. Some people thought it might be a hidden message, but it actually just shows how the signal's intensity changed over time. The wow signal sparked all kinds of theories. Some people believed it was a sign of extraterrestrial life, while others were sure that it was some interference from human activities. There were those who believed it could be a natural phenomenon we didn't understand yet. New research seems to have finally solved the mystery, but there's one thing we'll talk about a bit later. First, let's get into detail. A team of scientists, led by Abel Mendez from the Planetary Habitability Laboratory at the University of Puerto Rico at Arecibo, revisited the mystery using data from the now-closed Arecibo Radio Telescope, collected between 2017 and 2020. These observations were similar to those made by Big Ear, but they had better sensitivity, resolution, and polarization measurements. Arecibo detected signals similar to the wow signal, but there were some important differences. These signals were less intense and came from multiple locations. The scientists believe that these signals, including the original wow signal, can be explained by natural events in space. Their theory sounds like this. The wow signal was likely caused by a sudden brightening of hydrogen due to a strong, short-lived radiation source. It could be a magnetar flare or a soft gamma repeater, SGR. A magnetar is a neutron star with a way stronger magnetic field than ordinary neutron stars. And an SGR is an astronomical object which emits large bursts of gamma rays and X-rays at irregular intervals. In any case, such events are pretty rare and depend on very specific conditions. But they can cause hydrogen clouds to light up for short periods. According to the researchers, what Big Ear picked up in 1977 was one of those bright hydrogen clouds in its line of sight. The study suggests that the signal's rarity can be explained by the precise alignment needed between the radiation source, the hydrogen cloud, and the observer. It means that the wow signal may actually be the first recorded instance of an astronomical maser flare in the hydrogen line,